I wanted to make a video on changing out these vacuum advanced canisters. These canisters can be kind of confusing. They're adjustable. I guess you buy mostly just aftermarket canisters now. So the canisters are adjustable. They come with some kind of odd instructions on how to adjust them and how to figure out how much total timing you need and how much actual timing that the canister applies under vacuum. So I wanted to walk through how simple it is to change these out and then kind of explain what it's doing along the way, as well as make a video on the procedure to actually change it. So the first thing I want to walk through is how to test it to see if it's actually working. When these canisters fail, they can actually just cause a direct vacuum leak, and so your engine can run lean, it's not getting the timing it needs, and you end up with a lot of worsened performance with a failed canister that you may not know about. So what we'll do is walk through how to test this with a simple vacuum pump that you'd use on your brake system to bleed your brakes. So I'll show you what happens inside the distributor actually. So when you pop the caps, we pop the locks back here, we can see underneath the distributor and see how things are working. And we'll zoom in here. So what this is doing is when the engine has a vacuum, typically under idle or some sort of a cruise condition, you would generally see that vacuum would be applied from the engine into the end of the canister, and as the vacuum is applied, the inside, the plate that the points sit on, and the vacuum actually pulls on the canister here, and what it does is pull some additional advance via moving the timing base plate here, and it pulls it forward and it actually adds advance to the timing. So when this thing doesn't work, it's just open on the inside, and what you have is a vacuum that's trying to, and instead of pulling against the diaphragm, it's just pulling air from inside the distributor and pulling it straight into the engine, which isn't helping because this plate isn't actually advancing, and so you don't have your full vacuum advance that you'd see under normal conditions. So it helps to have an advanced timing curve under idle, and under cruise conditions it gives you cooler idling temperatures typically, and better throttle response. And so the same thing happens when you're cruising down the road. Under very light loads, the engine can handle a lot of timing, and you get cooler temperatures, typically better fuel mileage, as well as a better throttle response when you need to pass somebody going down the road. So I just want to walk through the way I tested this with a simple brake bleeder tool. So all I've done here is disconnect the hose that goes into the carburetor or to a ported vacuum or a vacuum port on the manifold, and plugged it into the end of the brake bleed tool here. So we try to apply vacuum, and so you pump this up, and it should be holding a vacuum. This gauge should be going up and showing us that it's pulling a vacuum. We can see that the gauge is good when I hold my finger over the end of the hose here and pull it. You can see that it pulls a vacuum on there and it actually holds. Let it go and vacuum falls off. So the engine's seeing the same thing. The engine goes to pull a vacuum on the end of this canister here, and it is just straight open air it's pulling in. The way this should work is this replacement part here. We can demo this piece and actually see what it's doing. It's brand new out of the box. So when I hook the vacuum hose up to the end of this, we can see via this marker line I put on the end of it right here, and as we pull vacuum, so we can get this all in one shot here, And as I pull a vacuum, you see the inside, the arm actually pulls in as this pump applies vacuum pressure to it. And so I can press the release button, we can release the vacuum here, and you see the actuation arm actually come back out, which would in turn retard the timing back to a safer condition. So we'll show that one more time. And we can see the diaphragm actually draw the arm in, which would advance the timing on the distributor. And again, as the vacuum is reduced, then the arm just comes right back out. So what we're doing when we actually adjust these adjustable vacuum advance canisters, so what's happening here when we adjust the vacuum advance canister here with a screw inside, I've got a 3/32, just a T Allen key, and as I put this down inside of the vacuum port here, it actually grabs a hex head or an Allen key that's down in there. And what that does is you turn it counterclockwise and counterclockwise, it actually increases and decreases the amount of throw or the amount of advance that this arm can actually pull in. So if you want the maximum advance that this canister can provide, you would use it just like it comes out of the box. And the set screw in here is set all the way against the back wall. So you would turn it clockwise until it stops. You don't want to tighten it down by any means, you just want to feel it stop in there. And that's going to allow this actuation arm to move at its full capability or its full limits. So what that's going to do is add a lot or the most amount of vacuum advance possible to the plate on the distributor. That can be problematic because you can pull too much advance into there and you can end up with detonation and things you don't want, potentially backfiring and other host of issues. So if you are experiencing detonation at a cruise or under idle or something with one of these stock canisters, you may want to consider backing off that screw and limiting how much advance that this vacuum canister can provide. Vacuum canisters are an excellent idea. They make things idle better, especially for drivability. You see a lot of guys disable these going down the road, and on a motor that they use on the street, and I don't understand why you would bypass this. They are great for better idling, off idle acceleration, better like street manners when you're cruising down the highway and you want to just tip into the throttle a little bit and either pass somebody or just speed up a little. You get a lot better manners having a vacuum canister on here. If you're doing nothing but racing the car and the car never really sees vacuum because the throttle is always at a wide open throttle position, then okay, there's really no sense in you using the vacuum advance canister. In that case, you could plug it off, and you never see any advantage to using the vacuum canister because the engine would really never put any sort of vacuum on there, and other guys complain that they want more control over their distributor and they want to know exactly what it's doing, and they don't want the vacuum advance canister interrupting their timing curve. But for a street driven motor, I always recommend leaving these hooked up as long as they're in good operational condition. This truck was not in good condition, as we just saw by the test we did, but we'll go ahead and change this one out and then walk through the setup. Alright, so I'll try to take this clip off of here and try to get a good view what this clip looks like. Alright, so what I did was put the screwdriver tip in the edge of the clip and then just rolled it back out of there. you don't want to put a lot of pressure on it because you can shoot those clips off and then you lose them. I'm going to use a magnet to pull that clip out of there. Got it. So we'll set that guy aside carefully. And now this vacuum canister should have 2 screws in it here. This one only has 1, so I'll have to find another screw in a second. I'm just going to again take a screwdriver and put it underneath this arm here. And disconnect it, and we'll slide this vacuum canister out of here. Alright. So I found another screw. And the screw that I found is a little bit longer here, but it looks like it's got enough clearance to go kind of just hang out here in the middle of nowhere underneath the distributor. I got a good 3 to 4 inches here, and it's not going to impact anything. So we'll put this new screw on this side. So we'll take the new canister here, and I've set my starting position here. I've taken I'm going to take this canister, I'm going to set it at about 3.5 turns out, and we'll have to try to figure out how much vacuum advance that's actually putting into the distributor. So we're going to go half, 1, 1.5, 2, 2.5, 3, and 3.5. Let's see if you can see what I'm doing here. It just clips right back on top of there. It fits just like the factory one did. It aligns with the 2 holes, so we'll put the screws back in there and we'll carefully snap that E-clip back on. Snug that up and call it good. So now what we can do is retest this just to have a good example of what a good test would look like. So again, I'm going to take the vacuum gauge and we'll try to capture all this in one frame here. And I'm going to take the end of the hose that the vacuum pump is pulling against, and I'll pump this thing, and you can see it pulling the vacuum advance plate. There's like 23 inches of vacuum, which is probably more vacuum than this thing will pull, but it shows the plate pulling forward. And if we watch here, as soon as I press this button to release the vacuum, we see it pull back, which is pretty interesting. So that's what the last vacuum canister should have been doing, and it was not. But it's always neat to get a good visual of what's going on inside the distributor and actually understand how it's working. So I'll release the vacuum one more time. You can see the vacuum canister release and the plate and the distributor actually go back to its neutral position. I'm going to carefully take this clip and put it back on the tray so I can use some pliers to snap it back in place. It's kind of like playing that game Surgeon when you were a kid. The only difference here is that we don't get a buzzer if we mess up. We get to make a trip to the hardware store. And let's see. Alright, so there I've set it on the plate. And I'll try to find a pair of pliers or something now. So I've got some of these flat, wide tip, small needle nose. I'll just use that to clip it back in place here, I hope. Alright, so just snap back in. Ready to go. So we're going to hook the vacuum line up to the distributor advanced canister, and then we're going to hook the other end of the line to the hand vacuum pump. What we're going to do is manually inject vacuum, so the engine's not pulling a vacuum, but we're pulling the vacuum with the hand pump. So put the distributor back on here, put the distributor back together, and go ahead and start this truck up and try to calculate how much timing this thing's pulling in. So what I've done here is got the engine running, and well, here in a second I actually apply some vacuum with the vacuum pump, and it increases the timing. So it increases the vacuum and the timing goes up, and then we'll actually hear the engine RPM pick up here. And what I've done is put a pink line at the top dead center mark on the harmonic balancer, and I've got an inductive timing light, so as I adjust the timing marks digitally on the light, then it shows that mark, that TDC mark, back lined up as though it was lined up with the indicator on the block here. So what I'm doing now is just kind of dialing that up, so probably 28, 29, 30, and as we go up, the pink mark moves up to the indicator, and we know that whatever number the inductive timing light is showing me, that's how many degrees of timing are being pulled in to this engine at idle through the vacuum canister. And as we can see, we pull about 20 to 23 inches of vacuum on it, which may be a little more than the engine's going to ever pull on there, which should max the canister out. And so with that amount of vacuum on there, the canister is actually adding in, or is taking the total timing to around 41 degrees here, which is probably way too much. Alright, so you can see it was pulling almost 41 degrees of timing just sitting there idling. So that's way too much. We're going to back this limiter out a couple more turns, and it sounded like you could almost hear it like backfiring to the carburetor or something. It was really huffing and puffing, and just really wasn't happy. So what we'll do here is we'll back this out another we'll go 1.5 turns and see if it limits that canister to stop pulling and adding so much timing. But what I was interested in doing was seeing how much that vacuum advanced canister was going to be able to put into that distributor, and it looks like it's probably going to be a significant amount. So we'll start it up and check our timing again and see how much we were able to back off that advanced swing there. We'll move the camera back around, fire the truck up again, and perform the same test. So previously the canister was able to pull in about 29 degrees of additional timing with a vacuum. That's going to be way too much. So what we'll do here is apply vacuum to it manually with the vacuum pump. You can actually hear the idle pickup as we apply vacuum, and it actually pulls some more timing into the motor. So here's the gun again, set at 41 degrees, and looks like the mark's past the indicator. So we'll go ahead and back the gun off a little bit so it's showing us a more accurate reading. We'll focus here. Now we're down to 36 degrees. So this is 12 degrees plus 26. So it looks like now it's adding in about 24 degrees of timing via the vacuum canister. So I think that's probably a good setting for this motor. This is a pretty low compression engine, pretty low performance. And I can reach over here and turn the idle back down to make sure we got a good reading. The 800 RPM is probably a little bit too fast. Looks like it's sitting right around 36 degrees of timing at idle here. And that's a 12 degree static timing, so the distributor's physically rotated 12 degrees, and then it's pulling in an additional 24 with just off the manifold vacuum. Okay, so what do we do here? We started out, we added 12 degrees of timing to the distributor. This is our base timing. We get this by mechanically turning the distributor by hand and adjusting it with a timing light to get 12 degrees. Then, at 3600 RPM or so, the distributor adds in an additional 24 degrees of mechanical advance. This is what is called mechanical timing. This is what guys typically refer to as total timing. So you take your initial timing from when you set the distributor plus your mechanical timing that the distributor adds in from mechanical advance at roughly 3000, 3600 RPM, something like that. So we get 36 degrees total timing there. But now what we have is a vacuum canister. So this vacuum canister has the possibility to add in 24 additional degrees now with the way we have it set up. So that means at some point in time at the 3600 RPM, 4000 RPM highway speeds, if we take this thing to a full vacuum condition, it's possible that it could have 60 degrees of total possible advance. Maybe that's too much, maybe it's not. I think it's probably okay. This engine here, this Ford 360, is a super low compression engine. It's not turning very fast. I think it's probably pretty safe. So then here's the details on how I went through adjusting this vacuum canister. We started out by installing it with the initial setting at about 3.5 turns out. So that gave us a limit to where the vacuum canister would only add in 29 degrees of timing. I say only. That ended up being too much timing to add in. So what we did is we pulled the adjuster screw out an additional 1.5 turns, which gave us a total of 5 turns out of the adjustment screw. So then that limited the amount of advance that the canister would add in to only 24 degrees of advance. So that worked out pretty good. The engine seems pretty happy there. If we do some quick math there, it looks like the adjuster screw seems to limit the timing by about 3 degrees each time we take the limiter screw out 1 turn. So say that again, 1 turn of the adjuster screw limits the timing about 3 degrees, given this quick math here. If you guys are trying to set up your own canister, that looks like it's a decent rule of thumb there. Anyway, hope you guys enjoyed this video. Hope you found it useful. If you have any questions, comments, leave them in the bottom down there, and I'll try to answer them as quick as I can.